Yeah, sure. Let's just say yes. Hi, good morning, everybody. Actually, I live in San Francisco, which is a place that you can live if you have no other choice. I suppose it's not terrible. But I'm in the beautiful city of Antwerp, Belgium this morning, and it's kind of nice to be on the same time zone as y'all. So it's 8:57 where I am right now, and I suppose it's just about the same where you are, assuming, of course, that you're joining us from South Africa. Um, so good morning and good evening to anybody else who's joining online, and good afternoon and so on. My name is Josh Long, as was just well explained. I work on the Spring team as a Spring developer advocate. I'm a Kotlin Google developer expert, a Java champion, and I'm at your service. That's the most salient, important piece to keep in mind here, to keep top of mind, in fact. I'm achingly online. You can find me there if you have questions, comments, feedback, whatever that goes beyond our finite time together this morning. Please don't hesitate to reach out to me. There's my Twitter, my LinkedIn, and my email. Anybody here use email? Anybody? I noticed that somebody mentioned the meta. Did I actually hear that right? Did somebody say the metaverse? Is this going out on the metaverse? Are we the only three people using it right now? I'm excited about that. I didn't know that was going to happen. That's cool. Um, anyway, yeah, good stuff. Find me online. Find me there. I haven't joined the metaverse, but I suppose I'm making my entry there now or something like that. Yeah, YouTube. I have a series every Wednesday. I look at neat bits of Arcana in the Spring ecosystem. I have a podcast that goes out usually it's Thursday night in California in the States, which would be 9 hours from now. I would start thinking about releasing it, usually end of day Thursday. So indeed closer to 30 hours from now. And so by that point, of course, it's well into Friday for most of the rest of the world further east of me. But actually, as it happens, given my crazy schedule today, I've actually already put the episode out. So that's just gone out, I don't know, 20 minutes ago. Yeah, I'm just very happy to engage again beyond our short amount of time today. And we do have a lot of stuff to talk about. That's why I want to put all this stuff out there first and foremost. Also, the code that we're going to look at is here online on GitHub. So if you should want to consult that, if you want to play the home game, don't hesitate to follow along. There's the code for your own reference. Now, today, my friends, we're going to talk about Kubernetes native Java. That is to say, how to build applications that work well in production, where dollars to donuts, for better or for worse, most of the time these days, production is Kubernetes. I like Kubernetes. I think it's a really interesting way to build systems. It's like Lego bricks for infrastructure, and in that way, it's really amazing. And it's actually at the end of the day just kind of like an object server, right? It's just a very simple idea, and a lot of times the best ideas are just the really simple ones that just they compose well, they scale well in that way, and much the same way that Spring actually composes and scales out logically. So I like Kubernetes, but again, it's just production, right? It's just a means to an end. It's a way to get your software into production. And when I mean production, I mean into the hands of your users that will then remunerate you, or at least make it valuable for you to have done the work to get it to them in the first place, right? In some way, right? I could say customer, but that's not always strictly speaking the dynamic, but it's the user. That's the person who benefits from the software, that is glad to have it. That's the most important here. And so getting software into production is the key to everything we do. There's a lot of things you could do, but if you're not shipping, you're not doing the most important thing as a software engineer, or as a person in IT in general, right? Helping deliver value is what we're here for. So to that end, though I love Spring and I love building really clean, nice, elegant code bases, at the end of the day, the thing I care most about is shipping valuable software into production. And I'm not the only one, obviously. It's not like I've just become the first person to have stumbled upon that particular endorphin pump, but it is worth restating that production is super valuable. And a lot of organizations are discovering this themselves. They're discovering that the faster you can cycle, the faster you can have an idea and take that idea from code to customer, from concept to code to customer, the better, right? Going fast, by the way, in of itself isn't the goal, right? Any idiot can strap themselves into a Lamborghini and crash head on into a wall at high speed. That's not what I'm talking about here. What I'm talking about is delivering value and cycling, iterating as you deliver. So make a change, see it delivered to the customer, validate what you have built is what needed to be built and what they wanted to be built, and then improving upon that, right? That cycle time, the speed of cycle, the speed of iteration, that's what's so key here. And so a lot of organizations are looking for ways to further their cycle time, to improve their cycle time. And to that end, you've seen a lot of the buzzwords of the last 20 odd plus years to arise from all that, from that very understandable use case. These are not new concepts necessarily. Strictly speaking, it's not like we didn't have ways to deploy software, before the cloud. But cloud computing increases the velocity because it's so self-service, so dynamic. It's not like we didn't test software. It's not like a new thing. But test-driven development gives us a way to validate upfront, and to do so in a continuous fashion, that what we're building is what we want to have been built, and so on. Right? Cloud computing, test-driven development, microservices, continuous integration, continuous delivery, all these buzzwords that help you win buzzword bingo in the IT space. Really, the novelty there is not so much the individual thing, but it's more that these things are now faster, right? We have ways to do these things that we could do before much more quickly. And sure, there are some net new things that are brand new and novel in of themselves from the last 20 odd years. But I would wager that if you were really honest with yourself, you'd find that most of the interesting things are just about improving the speed at which we could already do things before. Again, super important to have speed because it allows you to build better, faster, and that's what we care about. Now, a logical step for a lot of organizations is, as you grow larger, you break apart the teams working on one piece of software into smaller teams, and correspondingly, you break the software into smaller pieces, and we call this microservices. It's a refactoring of the organizations that's building the software, not so much a refactoring of the code base. Obviously, there is some of that as well, but the key part there is that you're optimizing your teams to improve your software, right? It's a sort of a reaction, a response to the Conway to Conway's law, the idea that software is a mirror image of the organizational patterns of the teams that build the software, right? It's a reflection of that. And so if the communication patterns of the teams is dysfunctional, then so too will be the resulting software, right? And if you want to fix that dysfunctional software, you fix the dysfunctional teams. But as you do this, as you embrace lots of small services and you start creating more and more moving parts, well, things start to get a little bit more precarious, right? You've now run the risk of introducing the fallacies of distributed computing. You run the risk of running afoul of things like the idea that software that the network is not infinitely fast or always available, right? These things are laws of software that we all should understand and internalize, and yet so many of us fail to prepare for those eventualities when we build our production grade software. So today, my friends, we're going to take a look at the latest and greatest in the Spring Boot ecosystem, as I always do. And this is a great time to do that, by the by, because as we talk, it's 13 October 2022. We are, by even the most optimistic measures, or rather, most conservative measures, we are no more than, let's say, a month and 20 days or so. I think it's the end of November. I forget the exact date, but we're not even 2 months away from the Spring Framework 6 release and the Spring Boot 3 release on top of that. Now, these are new generational, once in a several year span releases. These are new foundational baselines that imply a lot of amazing opportunities for the next few years that will follow. We don't release new major releases of Spring Framework very often. The last one was Spring Framework 5, the current generation of software, in 2017, in September of 2017. So more than 5 years ago, half a decade ago. I don't know. It's hard to believe it's been 5 years because there was that sticky, 2 or 3 year period in the middle there with the pandemic that kind of dilates time. But yeah, it's been 5 years. And in that time, a lot has been done in the current 5X generation. But it is time to start, gearing up for the next revision, the next generation. And to that end, Spring Framework 6 and Spring Boot 3 on top of it represent a huge leap forward in what we've got, what is possible with Spring. There's a lot of new baselines. First of all, there's support, new baselines revision for Java 17. We are using the new Jakarta EE 10, I think, or maybe 9, probably 10 APIs. As well. Now, this is kind of an interesting point, friends. The Jakarta EE APIs are for non-technical reasons, they're going to break, right? Things are going to break. It's for politics and for nothing else that they break. And it's an easy enough change, but it will imply some breakage. What's happened is, I don't know how many of you remember this, but there was a time 5-6 years ago, something like that, where Oracle basically just ghosted the community and stopped responding to the community regarding the then JCP specifications. The result was that these specifications that were led by Oracle just languished, and without those specifications being moved forward, Java EE as a whole could not move forward. And this is bad if you care about things like JMS or JPA or the servlet specification or whatever, because none of these things could be released, right? So eventually, after a lot of public outrage and outcry, Oracle came back to the table just long enough to open source what was then part of the JCP process, the JCP specifications for Java EE, but only with the proviso that any new code added to these specifications, to these APIs, had to be done in terms of a new package. So it couldn't be done in the same namespace, the same Java package as it was before. So where before you might have used javax.persistence, you now use jakarta.persistence. Javax.jms is now jakarta.jms. Javax.servlet becomes jakarta.servlet, and so on and so on. So every bit of code ever written in the last 25 odd plus years against these APIs is now broken. But it's an easy enough fix, right? It's just find and replace. And I would be very surprised if your IDE, your favorite IDE, doesn't have some easy button you click and it'll just convert the code for you. It's simple enough to fix, right? And from a technical perspective, the folks working on the specifications over in Eclipse have done everything they reasonably could to make this transition as simple and painless as possible, going so far as to release a couple versions of Java EE and Jakarta EE, first with a new license and then with a new namespace and package and all that, with no changes otherwise. Nothing else. It's just so that you have an easy on-ramp to move your code, and all you have to do is do a find and replace. And the community has done this. The community has slowly done this, mind you, but it's happened. So now, today, you can use Tomcat and Jetty and Hibernate and all these sort of ecosystem projects that build atop these core specifications, and they all use the new Jakarta namespace, and so too does Spring Framework 6. So that's a big change there. Obviously, there's a new observability API in Spring Framework 6 and Spring Boot 3 as well, where we have unified distributed tracing and metrics inside of this new micrometer project and this new abstraction called the observation API that gives you a unified way to capture both tracing and statistics, metrics, things like that. And of course, we have AOT support. So lots of big stuff. And we'll talk about each of these points in turn in more or less detail in the next 50 odd minutes. But I just want to set the table here. Spring Framework 6 is just about here. It's time to try it out, my friends. Spring Boot 3 with it. And there's some amazing new opportunities here. And we're going to talk about some of that today. And of course, the big thing that I want to point out is that we're using Java 17. So we're going to build a new application today. We're going to build an application here at start.spring.io. We're going to build a new service. We're going to call this customers. I'm going to bring in H2, which is an in-memory embedded SQL database. I'm going to bring in R2DBC, which is a reactive relational database connectivity abstraction. I'm going to bring in the Spring Boot actuator. I'll bring in the reactive web support. And I'm going to leave everything else basically as is. I have here before me two choices, Java's 17 and 19. Java 17 is the current long-term supported version of Java, and therefore it's a solid choice if you have nowhere else on which to park your code. But Java 17 is the new implied baseline requirement for Spring Framework 6 and therefore Spring Boot 3. Bear in mind what I just said just a minute ago about the generation timeline, right? I can't see the future. No one can. But let's just extrapolate. Let's look forward a little bit. Let's suppose that the next major revision, Spring Framework 7, comes out 5 years hence, okay, or just a little bit more than 5 years, 5 years after the release of Spring Framework 6 or so. So extrapolating, given that there's a new version of Java every 6 months, which is amazing, by the way. Thank you, Oracle, for that. That's it's been a boon to the ecosystem. It's made this an amazing ecosystem to be in. And by the way, I just love Java. I love it because it represents decades and millions of human hours of R&D over those decades. Not to mention, I can't even imagine countless amounts of money poured in by countless amounts of companies countless organizations, countless engineers. It's got to be north of billions of dollars at this point. It has to be, right? It's a staggering achievement what the Java project has achieved in its time, and what it continues to achieve, and the new horizons that it continuously sets forward for all of us. And it's open source. They give it away. It's crazy. So thank you, Oracle, for that. So Java 17 is a great revision, but again, they're releasing new versions every 6 months. What does that mean? Well, that means that every year you get 2 versions of Java, and looking forward to 5 years hence, that's 10 versions of Java. The current GA 6 month long, 6 month supported version of Java is Java 19, so it's already been a year since Java 17, and Spring Framework 6 will support Java 17. Let's say it's another 5 years after the release, so it's already been a year of Java 17, and you'll have another year of it. That'll be 6 years since Java 17 came out. And by that metric, then of course, Java 17 is going to seem very indulgent, right? I mean, can you imagine 6 years from now still writing code on Java 17 and have it being supported when at that point Java 29 will be out? It's going to be pretty crazy. I love Java 17. You should love Java 17. It's faster. It's technically superior to Java 8 in every way. It's faster, more syntax rich, more performant, more robust, more operations friendly, more container friendly. It's technically superior in every way. It's also morally superior to Java 8 in every way. You won't like the look of despair and sadness in your children's faces when they find that you're using Java 8 in production. Don't do it. Be the change you want to see in the world, my friends. Do the right thing. Java 17 is the right thing to do in 2022. So to that end, I'm going to use Java 17. It happens to be the revision against which the current sort of main version of GraalVM is built. So I'm happy with that. Let's go ahead and hit generate, and we'll just open this up in our IDE. I'm using the 3.0 M5, but again, this is a creakingly old version of Spring Boot that came out a couple weeks ago. So now I wouldn't be surprised if there's another one coming. After all, we just announced Spring Framework 6 RC1. I think that was yesterday, or maybe it was even today, where Spring Framework 6 is now basically feature complete. So barring some substantial, show-stopping bugs or whatever, what's in there today is what will be there in the GA, right? So we're very close to all that. So customers, we're building a new application here. Customer application. I'm going to build an application that talks to an embedded SQL database. I've got H2, so I need to initialize that database. I'll create a new file here called schema, create table, customer, ID, serial, primary key, name, var, car, 255, not null. Okay, and we're going to now create an application to manage data in terms of that database. Okay, so I'll create a record here. This is a Java 16 or 15 ism. Look, Ma, no Lombok. Isn't that delightful? So I just have this little record to describe my entity. I'm going to create a repository, customer repository, extends reactive CRUD repository, managing entities of type customer. Okay, so customer, integer, primary key, and of course I'm going to create a HTTP endpoint. So I'll say customer HTTP controller. Voila. And I'll use customer repository. Okay, we'll inject that into the constructor there, thusly. We're going to create an @controller, @response body, and we'll create an endpoint here. Git mapping, customers, publisher, flux, customer, git. All right, good stuff. So return this .repository.find all. Voila. Okay, so there's my basic HTTP endpoint. Now, naturally, I need to have some data in the database, so I'll create a thing that will listen for an application ready event, and it'll just be an application event that gets published by the Spring Framework when the application context is fully initialized, and it's therefore appropriate to then write data to the database. Okay, so we're going to create a reactive stream with some people on the Spring team. Obviously, I'm there. Don't ask me how, but I am. Jurgen, the one, the only, the amazing, the incomparable. These are all, every person I'm about to list here, and indeed every person I haven't listed on the Spring team is just of the utmost caliber, myself being the obvious and notable exception, of course. So who else is on the Spring team? We've got Stefan, Chloe, Dr. Sire, Spencer, whatever. Okay, so I'm going to go through. I've got a bunch of names there. No, like so. I'm going to write that out. Repository.save C, and then I'll just, as I write everything out to the database, I'm just going to enumerate every record I get back, and then log it out. Right. So there we go. There's my basic reactive data set, and this is only because I'm doing a demo. Obviously, you wouldn't do this in your production code because you'd actually have production data, but this is a demo, and there if I need something like that. So let's go ahead and start the application. We'll let it do its thing. Okay, good. So it's worked. Of course it worked. It was a demo. That was always going to work. That's not why we're here. What I care about is getting this application to production. So obviously, I've got this application. It's doing its thing using Spring Boot 2.0 M5. Good stuff. First thing I care about is observability. And to that end, I've got the Spring Boot starter actuator dependency on the class path, which surfaces a set of managed HTTP endpoints. It gives me information about the state of the service itself. So I can expose all these endpoints so that we can inspect them in detail here. But naturally, you wouldn't do this in a production environment because this exposes everything, and you might want to be a little bit more methodical in what you expose and what you surface and what you secure and what you don't, etc. So let's go ahead and restart this now with that change made. Here we are. Okay. What? Oh, it started up 2 instead of just recycling the existing one. Why? Why would you do that? Let's see. Restart. Has my IDE taken a walkabout? What's going on here? Okay, so localhost customers. There we are. There's the data. But now, actuator is a root endpoint, and we have all these different endpoints underneath it, like health, like metrics, like info, like env, like heap, dump, etc. Right? These endpoints give you information about the application. So I showed you metrics, and that uses the aforementioned Micrometer project. Micrometer is a vendor-neutral application metrics facade that allows you to publish metrics to time series databases like ApptOptics and Prometheus, very common in the Kubernetes space, and Azure Monitor, and all this good stuff, right? It's also the distributed tracing solution going forward, right? So it's a very interesting project, and you can use this information here. I just got it in the JVM at the moment, but I could publish that to a single pane of glass to make it easier to surface statistics that help me understand how my application is doing in production. This becomes even more valuable when you consider that GraalVM, powerful though it is, doesn't have a great story right now for Java agents, which are a critical part of many different vendors' monitoring solutions, right? They give you a Java agent that you plug into the JVM, and it sort of sits there off to the side running in process, but not part of your business logic itself, and it captures information about the running application. Here, the instrumentation is being done in the framework level, so it's part of your code base. You ship it in your code. It's not a thing added later on, and when you compile this code into a GraalVM native image, it still works, right? So keep that in mind. I love that about the actuator support here. But let's go back to that health endpoint. This health endpoint gives me an enumeration of all the different subsystems in the application that, were they to fail, would imperil the health of the overall service. Things like the database, the connection pool for the database here, things like my file system. Naturally, if I don't have a file system, I can't very well do all the things I need a file system for, like, logs and whatever. So all these things are important. In the Kubernetes space, however, you actually need 2 different kinds of health indicators, not just one global one, but you have 2 use cases. The first is I need a health indicator that tells me if my service is ready to go into production. Okay, and that's the readiness endpoint. Health readiness, right? The readiness endpoint tells me if the service is fit for service. And once it's in production, I have the liveness endpoint, which tells me whether the service is able to stay in production. If for whatever reason something has gone wrong, it cannot reach its database, it's got, it's run out of space or whatever, this will reflect that the service is sick, and therefore it should be taken out of rotation. Your container orchestrator, Kubernetes, we assume in this case, will come along and kill the pod in which your process is running, and then deploy a new one in the to compensate, to rebalance the cluster. Well, what happens to your existing application, your existing Spring application, as you've got this container orchestrator coming to try and shut down the pod and your process with it. Well, you need to make sure that you gracefully clean up any in-flight transactions, any state that you've got before that happens. And so you can enable graceful shutdown. Okay, so shutdown is by default immediate, but you can enable graceful shutdown. And what that does is when Kubernetes sees that your app is sick, it kills the pod. It does that by first sending a sig term signal, and then almost immediately in succession, it sends sig kill. Right, so these are two POSIX signals, and usually there's no gap in between the two. But here you can specify, hey, I want to have 30 seconds, and of course there's a corresponding configuration property that you specify in your pod or your deployment that specifies the timeout, the delta between your sig turn and sig kill. But assuming those two values line up between what you have here in the Spring Boot configuration and what's in your Kubernetes, your YAML for your Kubernetes file, then this will mean that your application will take a sig term. It'll start shutting everything down. It'll stop accepting new HTTP requests, and it'll let you taper off any in-flight transactions, any in-flight traffic and requests within that 30 seconds. And of course, if they're all cleaned up and done and resolved by that 30-second duration, then great. It'll just shut everything down and exit gracefully. If not, then of course, Kubernetes will now do sig kill and force the process to shut down. But this gives you, now gives you a way to understand what happens when your application is now is being decommissioned and updated. Okay, so graceful shutdown is great. This is, these probes are Kubernetes specific things as well. There's a lot of things you might want to do here, and in a Kubernetes environment, this kind of configuration could live in a property file, but it could just as easily live in the Kubernetes environment itself. And there are two ways to get configuration into a application running on Kubernetes. You can use a config map or a secret. These are both objects that live in Kubernetes, and they're both basically just dictionaries, one having not encrypted, but encoded passwords, and the other one not, right? And basically, these keys and values can be made available. They can be exposed to your application in one of two different ways. One is they can be turned into an environment, in which case the environment, the keys and the config map or the secrets become environment variables in the application. And the values for those environment variables come from, of course, the values in the config map or the secret. Another way you could get that configuration is to have the configuration turned into a file system, and we call that a config tree. So let's suppose I go to the desktop here, make dir config, cd config, and I say echo 9090 to a file called server.port. Well, you might recognize that as a property that you can specify here, right? By default, it's equal to 70, it's equal to 8080, but I've set it to 9090, and I want to import that configuration as I might if that configuration were sourced from a config tree, from a config map that Kubernetes had turned into a config tree. So in order to do that, I could say, okay, when in Kubernetes, import this configuration from this directory on the desktop in the home directory, right? So I'm getting the directory structure full of configuration, which looks exactly like the configuration structure, the directory structure you might get when using Kubernetes. Okay, so let's just restart that and see what we get. Okay, and the application spun up and it's here on port 9090. Very good. So now we have overridden the default configuration by bringing in configuration in a Kubernetes context. So there's a lot of stuff you can do here to make your application do the right thing. I'm very confused by why I have two versions of the app running here. Okay, that explains. Okay, good. Okay, good. So that still 9090. Yeah, great. Okay, it's on port 9090. So, a lot of things you can do here to accommodate the fact that you're running in Kubernetes. We've looked at observability. We've looked at configuration. We looked at Kubernetes specific configuration. Let's move on now. I don't care about all this. Let's just get rid of all that because it's nice to have, but I don't want that. Obviously you should revisit that for yourself. What I want to focus now on is getting this application into production. And there's a lot of discussions here. The first and most obvious of which is, hey, I want to package this application up for production, where today production is dollars to donuts, something like Kubernetes. That said, by the way, I should mention, I would be remiss if I didn't mention, there is a really, really nice alternative just for Spring developers called Azure Spring Apps, which is a joint initiative that the Spring team and the good folks over at Microsoft co-developed. It's a platform as a service. You can use that, and that's a far more easy than using something like Kubernetes. You just give it a jar and it deploys that. But that I couldn't fill a whole hour talk on just something like that because it just takes a minute. So back to this. If I want to deploy it to something else where I have to do a little bit more work, a lot more work, I need to have a Docker container, right? And to get that Docker container, I can use a project like BuildPacks. And so BuildPacks, this is a cloud native computing foundation and project, and it's a way to take an artifact, be it a .jar, .war, Ruby on Rails app, a Python app, a Node app, a Ruby on Rails app, a PHP, a PHP. I cannot say it. It's not a language. I refuse to say this. If you use any of those technologies and that other one, you can take that artifact and turn it into a container with build packs. There's a CLI, pack CLI, so you can say pack build space and then feed it in the builder that you want to use, and then it'll dump out a Docker container that you can then Docker tag and Docker push to your container registry of choice. Now, you don't have to use the pack CLI. You could, but you don't have to, because for Spring Boot developers in particular, it's built in, right? So you can say Maven Spring Boot :build -image, and that'll be great. It'll give you a Docker image. You don't have to use Kubernetes for that. Obviously, you need containers for Kubernetes, but containers are useful in all sorts of other contexts. Azure containers, to name but one, for example. So, you've got a lot of options there. But I want to go a step further. I want to make this application as efficient as possible in production. And to that end, I want to look at GraalVM. So GraalVM is an open JDK drop-in replacement, but it has a particular tool called the native image compiler that lets you compile your applications into native images, operating system and architecture specific binaries. This native image compiler is an amazing piece of technology that has taken I think it's born of like more than a decade's worth of research and effort. So it's really a fascinating piece of tech. And the way it works is it analyzes your code at compile time, and it does what's called a reachability analysis. It looks at your main code. It looks at all the types that your main code is using. It looks at all the types that code is using. It looks at all the types that code is then using, and so on down the line until it arrives at such a point where it has all the types it thinks, based on its compile time only analysis, the static analysis, that you're going to use in production at runtime. The trouble is that, of course, for all of Java's stodginess and sometimes verbose syntax, it's actually a really dynamic language, and it has a lot more in common with the likes of Lisp and Ruby and Lua and Perl and JavaScript and Python and whatever, right? More dynamic, so-called scripting languages. You can actually do the equivalent of eval. You can create a Java class that you can write Java code in a Java lang string. You can write the syntax for a Java class file in a Java lang string, compile that at runtime in your code while it's running into a .class file, load that class file into the class loader, reflectively create an instance of that new class using reflection and class.forName and all that, invoke methods against it. You can serialize it if it implements serializable. You can create JDK proxies out of it if it's an interface. You can do all sorts of things all after the application is started, right? You can do the equivalent of eval, like in JavaScript or Python or whatever. There's this eval function where you can take a code block in a string and have it interpreted live in the middle of the running code. You can do that in a very roundabout way in Java too. And this just speaks to the power of Java. It's a very dynamic runtime. That dynamic runtime comes, however, at a bit of a cost, which is that you have all this extra stuff that's there just in case, right? Just in case you do end up using it in some unforeseen way. And if you're sure you're not going to use that, then GraalVM can be very good. If you are going to use something in a dynamic way like this, as is wont to happen in the Java ecosystem, then you need to tell GraalVM about what you're doing. You need to tell it about any reflection, serialization, proxies, JNI, resource loading, jar property files and icons and whatever. All that stuff will run afoul of the static analysis that GraalVM does. So you need to make sure you account for all of that in configuration files. So what we have done in Spring Framework 6 and Spring Boot 3 on top of it is we've created a component model that runs at compile time. You get a chance to actually post-process your bean factory, your object graph with all the different beans, and based on that, contribute extra metadata that GraalVM can then use to account for all these dynamic things that you do. Now, for 99% of the scenarios, Spring will just do it for you. We already know how you're doing all these dynamic things, all these CGlib proxies and JDK proxies and AOP and reflection, all that stuff that Spring knows about, it will account for and it'll do it for you. But there are some use cases where, of course, some third-party library might do something a little strange that Spring can't possibly foresee. And so you have this component model that you can use to tap into the compile time lifecycle and programmatically contribute these hints. Now, for our application, for this particular application, we don't need to worry about that, right? This is a very boilerplate, bread and butter kind of application. So clean package. We'll let that do its thing. It takes, I don't know, a minute, something like that, for this to compile. And that's a far sight better in large part to owing in large part to the amazing improvements that the GraalVM team has made in the last few years, and also to the leaps and bounds that the Spring team has made in the last few years. I have been talking to people about using Spring and GraalVM together since early 2020, since March of 2020, which famously, that nothing particularly important happened that month. Oh wait, the pandemic. Yeah. So I'll never forget that time. We had COVID, which is definitely the worst thing. And then a sort of distant number two was, it took 10 minutes to compile a GraalVM image, which is it's not good. It's not great. I didn't love it, but the GraalVM team has just done, made amazing progress on the last couple of years, and it shows. So the result is what you see here before you. This will compile, and by the way, it takes far less memory than it used to. It used to take tens of gigabytes of RAM to do this compilation. Now it's taking, less, mercifully. So target, and now I have this application called customers. If I do DUHS customers, it's 83 megs. Their application, I can run this. Oops, health. Oh, that's kind of interesting. Oh, that's been fixed, friends. You know what I didn't do? I am using 3.0 M5 when I should be using the snapshots. Again, they're making changes so quickly. So do I want to download all the dependencies? Nah, let's just comment this out. Just trust me. Download the code, update it to the snapshots, and that'll work for you. But in our case, we're just going to update this one more time. This will take another minute. That's okay. So it's going to do its thing in the background, and it'll eventually spin up an application. We'll see it working, and you'll see that it'll be very quick. But in the meantime, we should build a client, something that we can use to talk to it. So I'm going to build an edge service here, capital Edge 1. And I'm going to use the reactive web support. I'll use Spring for GraphQL. I'll use Spring Cloud Gateway. And I'll use Lombok. I'll use Lombok. I'm going to use the Spring Boot 2.7 generation. It doesn't really matter for this particular demo. We'll hit generate. CD downloads UAO edge 1.zip. And let's check in our build, still building. And this edge service is going to be a thing that sits at the logical edge of the architecture. It is the first port of call for requests in going to the downstream service from the outside world. So your clients, your iPhones, your Android devices, your computers, your laptops, your iPads, your watches, your cars, your whatever, all of them have SDKs, and all of them have the ability to send requests to your API. And rather than make every single client do all the work it needs to do to talk to every single microservice, instead you funnel all those requests to this edge service, where then you can accommodate any nuances about, in each client, the bandwidth and protocol varieties and all that kind of stuff. So this is a logical thing. It's called the edge service. And there you can do things like use an API gateway or a micro proxy. So we'll look at that in a second, but let's quickly return to this. There we go. There's our application. It's up and running. Oops, Control C did for no reason. Target customers. That took 59 milliseconds, which 54 milliseconds, which is 54 thousandths of a second to get going, which isn't all that interesting because, again, this is a long-lived web app, so who cares? But I do love the memory footprint. So here's the PID for my application. Okay, the PID, process identifier, and I have a little script here, Josh env, cat Josh env bin RSS by PID. I've got the little script here. All it does is ps -o RSS, gives you the PID, and then formats it to log out and scale out the results to make the values more meaningful. So I'm going to run that against the PID that I've just captured. So voila. There you go. So that application that we're running on my Mac at the moment is taking about 99 megs of RAM, which is great. That's a really, really good situation because remember, I bet dollars to donuts, most JVM applications you'll find in the wild, and there are a good many variety of workloads out there, but most of them are going to take at least a gig of RAM, right? So this is at least a 10x improvement, a factor of memory smaller, in terms of footprint. That means you can deploy 10 of these for the same resources, the same cost, especially in a metered environment like Kubernetes, as you would before on the JRE. This is a big deal. I won't say that the throughput is the same, right? This uses a different garbage collector, for example. So the garbage collector is not quite as efficient as the JRE. But again, you can do 10 of these where you can only do one of those before. So you can deploy 2 of these, and maybe that's enough to overcome the slight throughput gap, and you're still only taking 20% of the resources that your one instance did before. And now you've got, you're able to do load balancing, right? So it's a good deal for cloud environments, especially where you have to pay by metered resource usage, which is basically all of them. So we have our application, it's up and running. Let's go back to this edge service. I want to talk to that downstream service. That downstream service is on port 8080. So I'll make sure that this one starts on 9999. And here, I might want to use Spring Cloud Gateway, right? And actually this, I don't even need that. I could just put that in here. I'm going to create a Spring Bean of type route locator. Okay, route locator builder. And I'm going to create a definition of some routes. Now, routes in Spring Cloud Gateway describe incoming requests routed to port 9999 that have certain predicates, so path, proxy, for example, and then I'm going to describe the rules for what happens to those requests. So it matches on port 9999/proxy. I want to send it to the original customer service running on port 8080. I want to send it to the path customers, but of course, the path is already proxy, so I need to use filters to act on the incoming request and swap out the existing path of proxy and replace it with /customers so that when it gets forwarded to this URL, it becomes localhost 8080/customers. These filters are the real power of Spring Cloud Gateway, right? I can do things like rate limiting. I can do retries. I can add headers. I can do all sorts of interesting things here to make this application more palatable in whatever ways are required for the various clients that might consume it. Obviously, I've only begun to scratch the surface here, but this is one way to easily connect your clients to your downstream services, and it's minimally invasive. I'm operating here on the envelope of the message, not the payload proper. Another way that I might do that is to use reactive programming, which makes it very trivial to do, scatter, gather, service orchestration, and composition. And that's pretty trivial code to write. That's great, especially if you want to compose data or enrich data or in some way act on the payload proper and create a new view of the data tailored for the client, right? Because it's much better that we do that work here on the server side than to have your Android device on 3G roaming, costs with 2% battery. It's much better that you do that composition here on the server side and give the client one, one already constructed view of the data, one gulp of the data, rather than making that poor client we just described have to make 2 different or 3 different network calls and do multiple threads and wait for network latency to resolve and all that kind of stuff. So it's better to do that on the server side, and reactive programming makes that trivial. That said, it's still code. It's the easiest code you could write to do what we're trying to do. There is no more elegant way to do that on the JDK today or tomorrow. But it's still code that you have to write. And so what if we could get most of the benefits of that without having to write that kind of code? And that is actually possible. There's this incredible thing called GraphQL that was born at Facebook, now called Meta. And again, are we in the metaverse? That is so cool. I didn't even know. They created this thing in 2012 for their own particular use cases. They open sourced it in 2015. We have integrated it into Spring in their Spring for GraphQL project, and that's part of Spring Boot as well now. So as of Spring Boot 2.7. So here I want to create a schema, a GraphQL schema. I'll create a new folder here called GraphQL, and I'll create a new file called schema.graphqls, and I'll describe a type called query. Now this is a convention, but it's a convention to have all the read operations hang off of this type called query, right? So I'll say I'm going to return, when somebody asks for customers, I'm going to return an array, that's what these brackets mean, of type customer. Well, the type of customer is as follows. It's got an ID and it's got a name field. And doesn't this kind of vaguely sort of suggest Kotlin? If you look at it, it actually really, in my mind, it just maps very nicely and it's very easy to understand. Now, I haven't introduced this and we haven't looked at this, but let's suppose I had another service called the profile service. Okay, let's suppose that it had an ID. Logically, I think of the profile as being part of the customer, but I didn't introduce that when we built the customer service. We don't have a profile service, but let's suppose we wanted to create a view of the data, supposing that we had some third profile service out there where for every customer they could get the profile data. Okay, let's account for that here in our GraphQL code. So let's go back here. And we're going to build a class CRM GraphQL controller. Okay, I'm going to build a I'm going to build it in terms of that customer type, and of course that customer type is over on the customer service. So I'm going to do something terrible, something that you should never ever do ever, not even when you're all by yourself at home and no one is looking. I am going to go here and I'm going to copy and paste my code. Okay, so I'll go back here, paste, voila. I don't need this ID annotation. And here I'm going to create an endpoint to manage data for type customer whose field is named customers. I'm going to return all the customers from that backend service. Okay. Now, of course, in order to do that, I need to, no, not that. I need to, goodness, I am all over the place. There we go. I'm going to use this non-blocking HTTP client from Spring Framework, the web client, and I'll inject a bean. I'll define a bean of that type here. So I'll say return builder.build, and I'll say this.http.get.uri, HTTP localhost 8080 /customers.retrieve.body to flux customer.class. Okay, so there's my data. There's the stream, and I'm making the request. Now, what about that profile data? Well, let's create another endpoint here, and of course here. Oh, sorry, this is off query. Here, I'm going to have to do that. I'm going to resolve that profile in terms of the root of the aggregate, which is of type customer, and so the field is called profile, but the type is called customer. And I haven't introduced that type. We don't actually have that type anywhere. So let's just imagine that we do, right? So at record profile integer, blah, blah, blah. And so I'll say profile, but of course I need the pointer to the root of the aggregate so I can have Spring provide that here. And just for now, you can imagine I'm making a network call, but just for now, I'm just going to new up a new instance of that in terms of the ID that I get from the customer. So every profile will have the same ID as the customer to which it belongs. Okay, now here I've used at schema mapping. This is kind of like request mapping for regular HTTP. But this customer's endpoint, this field, is a query. It's a thing that hangs off this type that's conventional. All GraphQL programs will have a type for queries, another one for mutations, and another one for subscriptions. And this is just a convention that you'll see everywhere. So it's so common, in fact, that we've actually got a meta annotation, not the same as the metaverse, called at query mapping. And it gives you it gives you a default. It assumes the type is now equal to query, and it derives the name of the field from the name of the method. So this is semantically and executionally exactly the same as that. Okay. Now, of course, up here, knowing what I just told you, we can now drop that definition as well. And voila. Now, I want to inspect all this. I want to try this all out. So I'll go here and I'm going to enable the graphical console, and I'll just go ahead and restart the application. Okay, or start it. I'm not even sure that in all this time we've actually managed to start this thus far. So localhost 8080, 9090 / proxy. Is the service over here running? I assume it's running. Okay. Proxy localhost customers. This is, wait. What did I do here? 9999 proxy. Why isn't that resolving? Edge service being my gateway. I mean, I don't know. I don't even see any indicator that it's like even running. Localhost 8080. Go away. Sorry, 9999 proxy. There we go. I don't know what that was about. Okay, good. So there's my data being proxied from the downstream service. That means the gateway is working. What about the GraphQL stuff? So let's go to the console here, and you can see it's a built-in console that you can use to interact with your schema. GraphQL has schema, right? So I can actually say, okay, I want to create a query for customers, and if I hit Control Space, it prompts me with the data types that I want. Maybe I want the name, great. And if I ask for just the ID and the name, I get just the ID and the name. But let's suppose I do want that profile data. And again, you might have a different view of the data. You might have a search page that shows you just the abbreviated sort of summaries of the results, and then detailed page where you see the full object graph. Here, I can use the same GraphQL endpoint to power both views. I don't pay the cost of getting the profile data if I don't need it. If I don't involve it, if I don't explicitly spell out that I want it, then it doesn't bother materializing that part of the graph, right? This is why it's so very powerful. And my client doesn't know that these two things are actually two different network services. In this case, it's actually it's less than ideal, isn't it? Because I'm basically doing an n+1, right? For every customer, it's going to call this profile method and create a new profile, right? But of course, if this were a network call, that would mean you'd have n calls to the profile service for every single one customer. So you can actually consolidate this quite a bit by using batch mapping. And in this case, your job is to return a map of customer to profile for a list of customers, right? Like that. So that's what that would actually now give you a chance to resolve all the profiles for all the customers in one fell swoop. But I'm not going to bother implementing that because, again, I take it you can kind of understand what's happening already. Good stuff. Okay, good. So now we have our GraphQL endpoint. I wrote some low-level non-blocking HTTP code here. It wasn't that bad. I mean, really, this is pretty straight. It's as straightforward as any HTTP client on the market. That said, if you have enough endpoints, writing clients to talk to those endpoints will get pretty tedious at some point. And so, to that end, in Spring Framework 6, we have a new. This is another project here, Reactive Web 3.0 M5 hit generate. We have new support for declarative clients. So let's UAO Edge 2.zip. Okay. And this is a pretty straightforward thing to do, but what we're going to do is we're going to define a interface to talk to that service. We're going to define a type here, record customer, integer ID, string name. And I'm going to create an endpoint here that returns get all the customers. Thank you. And we'll say get exchange, and the endpoint is customers. Okay. So there's my basic interface definition. I want to create a bean that that materializes that interface, that implements it for me, and so that I don't have to actually do that work myself. So I'll say base URL is HTTP localhost 8080, and then .build. Now you might recognize this pattern if you've ever used Spring Cloud OpenFane or Spring Cloud Square Retrofit or Spring Cloud RetroSocket for RSocket-based services. But basically, it's now been simplified and it's now part of Spring Framework proper. So there you go. There's that. I need to create a HTTP service proxy factory. Turn new HTTP service proxy factory, and I need a HTTP client adapter. So HTTP client adapter. Okay, and in order for this to work, I need the web client itself. Return web client adapter dot for client, web client, etc. Okay, and I can return that here. So HTTP client adapter, and then finally, my CRM client here. I can build by using that HTTP service factory. So you'll have to write those first three bean definitions for any Spring application, right? But thereafter, you don't have to. You can just use the proxy factory to do the work of creating your implementations for you. So http.create client CRM client.class, and then you're done. So you can just define as many of these beans as you like for different interfaces, and assuming that this web client is configured the way you want it, then you're done, right? Okay, let's see. Restart. It's port. It's actually ignore that error there. That's just netty. Okay, so port 0. Now I'm going to run a different port, and I want to exercise this. I want to see it in action. So we'll create a application ready event. to just, when the application starts up, to enumerate all the results by using this CRM client that we just created. Okay, so CRM, and I'll say CRM.getCustomers.subscribe system out print line. Okay, so I'm just making a call using my new declarative client to get the data, and as results come by, I'm logging them out. All right, my friends, with that, we've looked at a number of different patterns that you can use to build better software intended for production in terms of Kubernetes and distributed systems and services. We highlighted a few, if not all, not even close to all, of the amazing new features in Spring Boot 3, which is in turn built on Spring Framework 6, which, as I just said, has a RC1 already out just yesterday, this week, certainly. So go check all that out. I have been Josh Long. Thank you so much for having me. I only wish that I could have been there in person. I have missed my time in South Africa, so I yearn to be able to return. But at this point, I'm happy to return, hand it over to you and answer questions and so on. Thank you so much.